Okay, Assalamualaikum and hello everyone. Today I'll be walking you through a case study from Business Mathematics 2. We will solve a simplex problem for backwell distributors and then interpret another case for Clapper Electronics. This presentation will show each step clearly, from setting up decision variables, building simplex table, doing pivots, all the way to find the optimal solution and understanding shadow price. So, for the next slide, what we will learn or deliverables are, we will cover four main things, which is first, how to define decision variables and write the linear programming model. Second, how to put the model into standard form for the simplex method. And then third, we'll go step by step through two simplex iterations, including choosing, entering and leaving variables with the ratio test. And finally, we will interpret the optimal plan, the maximum profit and also shadow prices for the second question. So for the question 1, the decision variables and data, we have three types of containers, which is class A, K and T. Let X be the number of A containers, X by the power of 2 the K containers, and the X power of 3 is the T containers. So here their profits are RM32, RM24 and RM56 respectively. In terms of resource, each container needs material and time. For example, A requires 2 kg of materials and 2 hours of time. For K, it only requires 1 kg and 6 hours, while T requires 3 kg and 4 hours. So, for here, the total availability is 120 kilograms of material and 240 hours of time. And most importantly, the company wants to use all the 240 hours. So, for the next slide, it is still question 1 but about the formulation. From the later information, we can now build the linear programming model. Our objective is to maximize profit, which is Z equals to 32 x by the power of 1 plus 24x by the power of 2 and plus 56 by the power of 3. The first constraint is material, which is 2x by the power of 1 plus 1x by the power of 2 and plus 3x by the power of 3 is less than or equal to 120. The second constraint is time, which is 2x by the power of 1 plus 6x by the power of 2 plus 4x by the power of 3 must equal to 140 since all hours are used. And of course, the variable must be non-negative. Okay, so for the next slide, which is still in question 1, is the standard form, which is the two-phase. To use simplex, we need standard form with equations. So for the material constraint, we add a select variable, which is s by the power of 1. That gives 2x by the power of 1 plus x by the power of 2 and plus 3x by the power of 3 plus s by the power of 1 equals to 120. For the time constraint, since it's an equality, we introduce an artificial variable, which is a by the power of 1. That gives 2x by the power of 1 plus 6x by the power of 2 plus 4x by the power of 3 plus a by the power of 1 equals to 240. Because we introduce an artificial variable, we must apply two-phase simplex method. In phase 1, we minimize a1 a by the power of 1 to drive it to 0. Simplex table, which is in phase 1. Here's our initial table. The basic variable are s by the power of 1 and a by the power of 1. Looking at the bottom row, the interim variable is x by the power of 2 because it has the largest positive value, which is 6. We now perform the ratio test for row 1. 120 divided by 1 equals to 120. For row 2, 240 divided by 6 equals to 40. The smallest ratio is 40. So, a by the power of 1 leave the basis and x by the power of 2 enters. So, for the next slide is pivot, which is the end phase of phase 1. After the pivot, x by the power of 2 become basics with value 40 and s by the power of 1 remains basic with the value 80. Since our artificial variable is gone, phase 1 ends successfully with w equal to 0. We now move to phase 2, which is using the real profit function. Okay, so in the next slide, which is still in question 1, the phase 2 start. For now, we bring back the true profit coefficients, which is 32 for x by the power of 1, 24 for x power of 2, 56 for x power of 3, and a 0 for slack. When we compute c by the power of j and minus z power of j, we see x by the power of 3 has the largest positive value, which is 40. So x by the power of 3 will enter the basis. We apply the ratio test again. So for row 1, 80 divided by 7 over 3 equals about 34.3. So for row 2, 40 divided by 2 over 3 equals to 60. So the smallest ratio is 34.3. So s power of 1 leave and x power of 3 enters. So for the slide number 9, which is still in question 1, which is the pivot 2, as known as optimal solution. After the second pivot, the new basis is x by the x power of 2 and x power of 3. The solution is x power of 2 equals to 120 over 7, which is about only 17.1. And x by the power of 3 equals to 240 over 7, which is about 34.3. And x by the power of 1 is 0. So the maximum profit is 16,320 over 7, or approximately 2,331 ringgit and 43 cent. Since all CJ minus and ZJ values are non-positive, the solution is optimal. Okay, for the next slide, which is slide number 10, which is still in question 1, for the interpretation, in simple terms, Backwell should produce about 70 units of class K and 34 units of class T. They should not produce class A at all. This way, they will fully use both the 240 hours of labor and the 120 kilograms of material, which is the maximum profit they can earn this week is 2,331 ringgit 43 cents. Okay, now we go to the second question, which is we will show the final table. Now let's move to question 2, which give us a final simplex table directly. We don't need to repeat the calculation. We just read the result from the table. So for the answers, for question 2, from A to D, from the table, the optimal production is 18 units of model 102 and 4 units of model H23. The maximum profit is 190. Both slack variable s by the power of 1 and s by the power of 2 are 0, which means soldering hours and inspection hours are fully used. The shadow price for soldering is 4 ringgit per hours. That means each extra soldering hours could increase profit by 4 ringgit. So renting a soldering machine at 2 ringgit and 50 cent per hour is worth it. And the shadow price for inspection is 1 ringgit per hour. Since hiring a part-time inspector costs 1 ringgit and 75 cent per hour, it is not worth it. So that's all for me. Thank you.